Cool. So today's webinar,
Okay.
we're going to be
Yeah.
talking about context engineering across realistic data sets. This is something that we hear a lot. People come in, they say, hey, we built a prototype on manufactured data, and then they try to roll it into production and they realize it's a little more challenging than that. So before we dive in, some quick intros on our side. My name is Kevin. I'm on the go-to-market team here at Unstructured. Think of me as the Ryan Seacrest of the webinars here. I am joined by Ajay, who is on our DevRel team. Thank you so much for joining.
Thank you. Thank you, Kevin.
Awesome. Some quick housekeeping items. Reminder that chat goes in chat. Please be talkative. If you do have questions, there is a separate tab for those questions, and we'll either get to those in real time or we have a Q&A section at the end of the call. We will send out a recording after the conversation today with a link to the video as well as resources to get started on Unstructured. And if you have specific use cases and you want to talk to an AI expert, go to our website, book a call. We're always happy to connect. All right, the agenda for today. We'll be talking about a couple of things. The data challenge, the access problem, so how do you get to the data, our unstructured solution with our uniform schema, and then Ajay is kind enough to do a live demo of our product in action. A little bit of background on unstructured. I've said this a couple times now. We started as an open source product 3 years ago, trying to answer the question, do companies struggle to take unstructured data and convert it into a structured JSON output? Flash forward to today, and it's been a pretty incredible ride. We have amazing customers, an incredible open source community, and a ton of amazing partners helping us solve this problem in the wild. And without further ado, I will turn it over to my better half, Ajay.
Thank you so much, Kevin. So, hey guys, super excited for this. So before we dive in, I just want to talk about firstly why all of this even matters. So according to Clean's research back in 2020 about hybrid workspace habits, they observed that employees spend a quarter of their work week, around 5 to 10 hours, on just searching for information they need to do their jobs. Like just 5 to 10 hours just trying to find other documents you need, reading from it to just do something that to just get through a blocker. And it's not really because, we're all just inefficient or anything. It's just because enterprise data is just everywhere and it's just carried across systems. You're going to find it in different file types. It's going to be in different folders that you would never think about looking at. And this is sort of this has been the reality of enterprise search today. So let me also drill down on what exactly I mean. So where does all of this data actually live? So what you're looking for might be an email thread, it might be a doc file, it might be something in your blob storage, yeah, or it might be a deck in your OneDrive, or it can also be something, yeah, it can also be something you have in Slack, it can be a file in your Box storage, Confluence, S3, and this list just goes on and on and on with more and more clients that you're onboarding, the more integrations you start pulling in. So overall, your data is just not in one place. It's scattered across every system your company needs. And that's not even the only problem you're dealing with. There's also the file type itself. Like you've connected, say you've managed to connect to all of these sources, you're able to pull all of this data successfully, and now you're hit with this, a W4 form. It's structured, yeah, it's a form, it's got these nice fields, it has a clear layout that we intuitively understand. So sure, makes sense. We could extract it, I guess. Sure. And then yeah, a client sends over, yeah, this. Like they send over a handwritten document. It's all just handwritten documents with, yeah, someone's handwriting overall. You need to spend some time for you understanding it yourself so that you can even start thinking about how you want to deal with it downstream. And then yeah, they might just start sending you these spreadsheets with merge tables. And it just overall every new client you work with yeah is just gonna have their own specific set of data formats. Maybe some of them might just have PDFs or maybe just emails, but I also heard that there's certain formats that's very specific to government documents as well. So there's all of these old and new formats, but unfortunately, all of these downstream systems don't really think about any of these complexities. All they want is the same thing. They just want a consistent, structured representation of like the same content with like a good schema, a good format, and a good level of quality. And that's the file level challenge that a lot of like traditional ETL just struggles to deal with. So how are we solving it itself? Well, unstructured, like with unstructured, we solve it by sitting right in the middle of your data pipeline. So you've got your systems of record on the left, you've got your production database, yeah, your production systems on the right. These can be your vector DBs, and you can have like other LLMs, you can have other tools connected to them. And with unstructured, like we just connect to all of your sources, pull your data, and give you a whole enterprise grade ETL workflow to pre-process all of that data. So we're going to handle all of that complexity of extraction, transformation, and loading. So you do not really have to think about even building one by yourself. But yeah, like this is a very high level thing. So let me just go in a level deeper. So here's what it actually looks like. We extract data from your sources. It can be like S3, SharePoint, anything. We transform it through a series of steps. Like we parse it, then we chunk it, we enrich it with metadata, then we generate embeddings for it, and then we push all of it right into like your destination. So pretty much regardless of the source, regardless of the file type, all of these go through the same partitioning strategies, enrichment steps, quality standards, and it all comes in on the other side as a very consistent normalized format right into like your vector store or database for like your downstream cases. And what I find cool about it is that like you don't really have to like write any glue code anymore. It's like you don't really have to think about maintaining parsers for a new file type. All of this is just coming in one bundled platform, and you're just getting results exactly where you need them to be at. So how did we actually go about like building this itself? Like it went like we went through a lot of work. The team went through so much work, and there's a lot of like important questions to like think about. So with that, first we built a single platform to handle any unstructured document, regardless of its format. This meant we integrated with like hundreds of open source libraries. We had to like bring in our own tooling to handle like other nuances. And then we also wanted a universal representation because, again, the downstream systems don't really care if something, your input data started as a PDF or a spreadsheet. Your LLMs, in the end, they just want consistent output. So we came up with this canonical JSON format that's rich enough to like handle complex spreadsheets, but also can handle your like basic text documents as well. And then third, just parsing accuracy itself. Like we still had to like think about dealing with scanned documents. We had to deal with like PDFs, PowerPoints, emails, like and like a lot of like different complex layouts that can come in like these documents as well. So for that, we also had to bring in OCR. We also had to bring in object detection models. We brought in vision language models. So that's pretty much like a foundation of sorts. We built one platform. We built this universal format, and now everything else you build just comes right over this. So a level deeper itself. So what actually happens when you pass a document through unstructured? Whether you upload a PDF, a Word document, a PowerPoint, or anything, unstructured is going to break it down, all of it into these standardized document elements. So the intuition we want you to like, I want you to take away from this is that you're going to get this document schema for like any of your input documents, and all of this is going to be standardized across like all of it, all of the types. So as long as like you understand the types, like you understand the schema and the nuances to it, you should be able to transfer that knowledge into your LLMs downstream as well, and they should be able to like handle it pretty well. And this is what I feel like is my definition of the term context engineering. Like it's not just about extracting text out of your data. It's also about preserving the structure and the meaning of your documents. So your generative AI systems actually understand the right context and data and can also like make the right decisions with that. So here's like a quick overview of how the document elements itself can look like. There's like a couple of examples I've taken. So we got titles, which can just be just the section titles itself. And then narrative text is just paragraphs and sentences, more like body content. Tables are all, since tables carry structure with them, we also like make sure they have a structured definition to it. And then we also encode images into like us like into a base64 format so that they can also be used downstream. So yeah, like it, and this is just like four examples, but there's so much more. Like we also recognize list items, we recognize headers, we recognize footers, like email addresses, page breaks. And like our intuition here is that we want to make sure each piece of your document gets classified and preserved so that you can pass all of that information into your downstream models. And this is where context engineering even comes into play. So when you're building these RAG applications, you don't just want to dump everything into a vector database as a raw text and just like pray that it works. Like you want to make sure like your model, like as much as you can tell by looking at these documents by default, you also want your LLMs to have that same knowledge as well. So yeah, like this whole structured definition really helps your LLM like also get that understanding that hey, this document that it's seeing is all like pretty structured and how it should interpret it itself. So let me just show you like how this also looks like in action. For example, I just took this PDF, like I just took this page out of a PDF. This table has a bunch of merged rows. It has like multiple columns. Like like it makes sense for us when we look at it, but it's kind of hard to transfer the same knowledge to an LLM when we're just like giving it raw text and asking it to like make inferences around the structure. So we give you like these multiple formats. First, just the text itself. And then we have HTML, which gives you like a structured representation of the table in a HTML format that, yeah, preserves like all the rows, columns, headers, and everything. And then we also give you a base64 image encoding of the table itself. So why these three formats itself? It's because, well, all these downstream use cases need different things. If you're dealing with semantic search, you might want just the raw text. If you're building like these RAG applications that need table structure, you'll need to use the HTML downstream. You could also pass in the image itself as context, and when you're dealing with a VLM itself. So this is my interpretation of context engineering in action. We're preserving data in all of these formats so that your generative AI systems can actually use it the way they need it to. But yeah, that's still only like half the story because even with all of these like perfect document processing, I think you still need to get the data from where it lives. I think that also falls under context engineering because it's more than just parsing the documents. You also need to access them, and that's where connectors come in. So yeah, like here's what I think. Like this is just my thoughts itself. I think connectors are extremely overrated. Sorry, extremely underrated. Oops. Extremely underrated. It's just because like all of us like when it comes to document AI, we all just see the parsing because it's very visible. You can see the output, you can verify it, you can, like drop a quantity, like you can quantify it, and all of it makes sense. But we don't really like think about connectors the same way. But if you really take a minute to think about it right now, like you understand that like they still need to like run 24/7. They need to like keep pulling data from all of these sources. You cannot expect them to fail because yeah, you just don't want them to fail, and there's still like 100 reasons why they could fail. For example, the vendor can change something on their end on the API side and your connector might just not work. So let's actually also just think about what it takes to build these production grade connectors for generative AI. So a couple of problems that we had to like think about solving itself. So our goal when we took up connectors was to build like something that handles all of this invisible complexity around accessing the data so that you do not have to think about it. And here's like some from the top of like my head that I put here itself. Firstly, all of these platforms think about data very differently. Like one slide, like one file per page makes sense when you're dealing with S3, but it doesn't make sense when you're dealing with Postgres. Like you cannot really put one row per call for one row per file, for example. And then these vendor errors can be extremely cryptic. Like a 404 doesn't always mean it's not found. Sometimes it can mean bad credentials. Sometimes the resource just moved. So we translate all of that into like clear, actionable messages. And then just there's this continuous maintenance as well. Like these vendors can change anything on their side, like routinely. So we run automated tests on every connector throughout the day to catch any breaking changes before like they end up like affecting you. And then there's change detection. This is my favorite because you don't really like want to process all of your documents every single time. So we instead track what's new, what's modified, what's deleted, and we only just sync what's actually changed. So now that I given you like a very high level overview of how we handle everything, let me just show you like how all of this looks in action itself. So I'm just gonna open up the unstructured platform. There's like cool UI and API quick starts if you wanna like check them out. And then I'm just gonna open up this workflow, build it myself. So what happens with a workflow? A workflow is essentially just a series of steps you want to happen on your data. Over here, what you're basically seeing right now is that you want data fetch from a source, you want a set of actions to happen, and then you want it pushed to this destination. If you're new to unstructured, I would recommend the partitioner is the parser. It's gonna fetch all the text out of the data. If you're new to unstructured, I would recommend using auto because we do the work of selecting the best parser based on like your file's complexity, your page's complexity itself. But right now, I'm just gonna use Hi-Res. Hi-Res has OCR models. Yeah, it's OCR backed, and we use like yeah. And then there's also VLMs if you're dealing with like extremely complex scan documents, handwritings, all of that. Yeah, so right now I'm gonna if my data my data in question had a bunch of images, so I added these image enrichments, these image description enrichments because adding these image descriptions like really help like bring the like it sort of like adds a biomarker to the image itself. So you can bring the image out and use that as context for your downstream tasks. It's really useful when your data has a bunch of um yeah, bunch of like your images have a bunch of information that you really want downstream. You can also do the same thing for tables. And then I'm gonna add a chunker, chunk by title, and then I'm gonna add an embedder, take up an embedding model. And the cool part for me is also that I can add multiple sources. So right now I'm just gonna add Outlook and then I'm gonna add an extra source. Let me see. Yep, OneDrive and one more, one more, Azure Blob. So right now, what basically happens is all of the data gets pulled from these like three sources from their specific folders, and they go through all of these steps, and they go right into this AstraDB, collection that I've set up. So yeah, like you can just hit run and all of this should work. But I'm also just going to show you like instead of disturbing the production workflow itself, I'm just going to pass a native file, like a simple file and show what it looks like in action. This takes a minute or so. So by true demo fashion, I'm just going to go next and show you like the pre-populated outputs itself. So this is the whole the canonical JSON representation I was telling you about. Like each document, like each part of your document has an element ID. All of them have a type, and based on their elements itself, we also have certain actions we do. For example, with this image itself, we are also extracting the text around the image. We are also providing like coordinates for it. And then there's the whole like the base64 encoding of the image I was telling you about that you could use downstream. And there's also outputs across like each node. So you can actually check how your data transforms at each and every step of the pipeline. So overall, like all of this really helps add in like more metadata, gives you more context of what you're looking at when you're thinking about your data. And it also gives you a picture of how you want things to work downstream because you sort of have an idea of how your context looks like, so you know how to engineer it for your LLMs. So now you should be able to like do a lot of like good work around it. Um, yeah, so that's pretty much around like what you could do with the data itself. So to summarize, to recap what we covered today, just all this multi-source RAG is extremely complex. Data lives in different places, and traditional ETL sort of struggles with this. So we built all of these connectors. We built a cool unified like canonical representation, and then yeah, to handle all of this so that you do not really have to think about doing all of this from scratch for your downstream use case. So that's the platform. And what I'm really excited about is also what we're excited about is also that the quality, like all of this data is just slowly like we're every day we're trying to like find new ways to improve how we use this data. So we're coming up with this cool new agentic document processing technique that like yeah uses agents to like know like use different techniques based on the elements itself. And then they structure data extraction to like extract very specific fields from your data. We are also like bringing in like working on this cool concept of helping an agent like access data in a secure manner so that they know so that they can fetch the exact data needed, like do the exact engineering needed around it and get you things yeah get things out for your downstream applications. And then we're also like bringing in more file types through the day. So yeah, that's sort of like what we've been up to and what we're like planning on doing more in the future. If you're also like interested, like we do these webinars every week. So last week we spoke about how OCR era benchmarks like fall short, and we came up with this cool new metric, like cool new like evaluation framework that really helps like that gives Gen AI like LLMs like treats LLMs like pretty like the way they're meant to be treated for evals. And then next week, we're talking a lot about like how we can deploy the whole system in like multiple different ways and the whole nuances around each and every use case itself. And with that, let's just open it up for questions.
Awesome. Ajay, thank you so much. We only got a few minutes, so let's kind of take a rapid fire approach to these.
Totally. Let's go.
Question. I will do them one at a time. Ajay, how do you
Mhm.
deal with short, incomplete answers provided that the context passed to the LLM has enough details?
Um, okay. Okay, is that the full question?
Yeah.
Okay, perfect.
I don't know if there's enough
So
context to answer that one.
okay. No, I think this, I think from what I understood, I think it just looks like short and complete answers just means that you're not giving your LLMs enough context to answer it. So maybe play around with the chunks itself, play around with the chunk sizes, the strategies, and check the quality of outputs. Yeah, basically just play experiment with the chunks. So that should give you a cool idea.
Awesome. Okay, when to employ hybrid search? When should companies think to employ hybrid search, i.e., adding BM25 to semantic search?
I guess BM25 is a very keyword related algorithm. So if your downstream use case involves a lot around specific keywords, specific terms, think about bringing in BM25 because semantic search again deals with meanings. So instead, what you could do is first use BM25 to get you a bunch of candidate chunks and then run semantic search over it to like get you more around the meaning that the user is looking for. So this can improve your quality.
Awesome. Okay, and then the last question is what approach helps to improve your RAG application? This is a very high level question, and like we can go down a bunch of rabbit holes around evals. And yes, evals are important, but at the end of the day, the only thing that really matters is that your end users are using your RAG applications. So like my feedback is like get your products in front of your customers, see what's working well, see what's not working well, see where the answers are falling short, and then iterate on that process. Ajay, how do you maintain data lineage and traceability when your RAG pipeline is pulling from multiple cloud and enterprise sources?
I think that's exactly where also the whole point of the workflow itself comes in, right? Like you are providing very clear steps on what action you want to happen on your data. So you sort of like know, okay, so you're adding a chunker, you're adding an enrichment, you're adding embedding. So with each and every step, you're able to like trace what's happening in every step. And I guess also take a look, like make use of the playground feature itself because you get node level outputs for each every component of the workflow. So you can exactly tell what's happening to your data at every level.
Okay. What is a good way to think about the verbose and unstructured knowledge source like Jira as opposed to other file type sources like PDF or Excels? And what are some good practices to follow to try to nail down signal from the noise? This is a very difficult question to answer in the abstract. I think a better way would be to like hop on a call and take a look at the documents that you're kind of visualizing here to get a sense on things like token density, what the structure of these documents looks like. But if you can nail transform quality and your chunking strategy, you don't have to worry as much. You can be confident that the output will work in whatever the RAG application is. I do want to apologize. We have a lot of other questions that we couldn't get to, but we will summarize and answer those in the email. I just want to say thank you to everyone for joining and the amazing questions we got, and we hope to see you next week. Have a good Wednesday, y'all.